Okay, so the review for the quiz, chapter 9. Start off with some vocabulary. Now, you can take this any way you want, any order you want. So, number one, major arc. Well, with the major arc, you know it should be either H or I. Why is that? Think about it. You want 3 letters. Okay? So C, E, G. Well, let's see, C, B, F. Let's see. C to B to F. Well, that doesn't look like a major arc because it's exactly a semicircle. Which, since that happens to be one of my choices, I'm going to go right down here now and just get that out of the way. Which leaves me with C, E, G. I don't assume, I double check it. C, sorry, gotta go to the E. So C to the E, past the semicircle, up to G, I got it. So that's I. Diameter, it's gotta be going through the center. Well, that doesn't go all the way across, that doesn't go all the way across. Here we go, right here, from C to F. So we're looking for CF and also with line segment over it. There it is. G. Only possibility there. Chord. Well, I'm looking for something like FE. Do I have FE? No, I don't. How about BG? Is there a BG on here? No, there's not, but those are chords. How about EG? Yes. Now notice, EG is a segment which is also part of a secant. If we kept going on and on this way and on this way. So I have a, right here, I have a chord within my secant. And I do have EG with line segment over it, so that is my chord. Minor arc. Well, I don't have any choices. Actually, I only have one choice, E, FD. But let's verify. FD, is that a minor arc? Yes, it is. Tangent line. Well, there's only one line outside the circle that's just hitting it at one point, B, right here, which is the tangent point, or point of tangency. So I need something that is with the B, I, or J. Here we go, IJ. 6, an interior point. Well, what are my choices? Point H, point A, and point I. I is outside. A and H are both inside. But A is also my center, and since number 9 I have center, I'm going to put D down here and B right here, point H. Secant line, we already talked about that. That was the one with IGHE. There's got to be a line, and the only line I have left is C, which is line GE, and that works. Exterior point, well, what's left? Only I, which is outside the circle, and I'm done with my section of vocabulary. Okay, find the measure of each numbered angle. Well, the measure of angle 1, whoops. Okay, minor technical difficulty. That was the quiz that we scrapped. So let's try this one now. This looks a little bit better. Okay, so we're trying to find the measure of angle 1. Well, the measure of angle 1 is 360 minus the combination of those two. So if you add those two together, you get 212. And if you do 360 minus 212, you end up with 148 degrees. And the measure of R2 is 60, same as the central angle. Okay, number 12. This is 68 right here. And since this is a semicircle, if we do 90 plus 68, we get 158. If we do 180 minus 158, we get 22. So this is 22. Angle 1 is vertical to that, so that's 22 also. Another way to look at it is right here we have another semicircle, so 90 plus 68, which is what we already did, that's why they're both 22. So 1 and 3 are both 22 degrees. And our 2, well, what we need to do is add up 90 plus 22 plus 22 plus 68, and then subtract that from 360. And that gives us 158 degrees. Number 13, notice we have a diameter, a semicircle, however you want to look at, which is 180 degrees. So we need to do 180 minus 64, which is 116 degrees. That's angle 1. And angle 2 is the other half of the semicircle, 180 degrees. Okay, number 14, real quickly. If you think about it, 3, negative 5 is somewhere down here. Negative 2, 1 is up there. We're going from A to B. That's important, remember? That's very important that all these are going from A to B. Make sure on the test you pay attention if it's switched. That means, remember, start with the end in mind. So this is our most important point right here for vectoring and for scale factor. So always start with the end in mind. So think about it. If I start down here, I'm starting at 3, negative 5, and I want to come up there. I need to go left and up, which means my vector should be negative, positive, right? Think ahead what you should expect. Now, how do I do this? Start with the end in mind. Negative 2 minus 3. That's x minus x. But the one you start with is very important. That's negative 5. I wanted a negative, yay. Then I'm going to do 1 minus negative 5, y minus y. That becomes adding 6, positive. That's what I wanted. Negative 5, 6. Now my scale factor is simply this radius written over this radius, 3/4. Okay, number 15. We're going to do 4 minus 7, which is negative 3. Sorry, no, I'm not. That's just a silly mistake. X minus x is right there. 4 minus 2, which is 2. And negative 3 minus 7, which is negative 10. Again, if you wanted to rough sketch it, 2, 7 is going to be somewhere up there. 4, negative 3 is going to be over there. So we're going to want to go right and down to get there. Scale factor, we literally just write 5 over 2, 5 halves. The new radius over the starting radius. Okay, negative 3 minus negative 8, which means plus. That's 5. 6 minus 0, well, that's just 6. And then, again, 4 over 6, or 2/3. Either one is appropriate. I'll accept either answer. Convert into radians. Remember, don't forget to write the word radians, or at least rad, on all these. So here, we're going to multiply by pi over 180. Again, you can go ahead and write 330 over 180 and then reduce, or you can reduce beforehand. First thing I would do is knock off 10. Divide both of them by 10. Now I got 33 over 18. What goes into both of those? 3. How many times? 11 times and 6 times. Don't forget the pi and radians, rad. 11/6 pi, or 11 pi over 6, rads. Okay, again, over 1, pi over 180. Reduce it any way you want. 4 goes into both of them. 12 goes into both of them. So if you recognize that 12 goes into 180, you got a little quicker. So 12 goes into 24 2 times, into 180 15 times. So that's 2 pi 15 radians. Okay, 225 over 1, pi over 180. What goes into both? 9, 5 goes into both. And you have a 45 over 36. And then you can divide by 5 again if you want, 3 if you want. But it reduces down to 5/4 pi radians. And then 150. You know, here's another trick. You just write 180 underneath it and put the pi out here. Divide by 10, you got 15 over 18. 3 goes in 5 times, 6 times, pi radians. Okay, now we're going the other direction. Notice the pi on the top. So we're going to put a pi on the bottom to cancel. And you can go through and do that right away because you want the pi's to cancel. The whole reason we're doing this. And then we just put 180 on top. All of these. Again, anything you want to do. If you want to do 4 times 180 divided by 9, or 9 into 180 times 4, doesn't matter. Just use your calculator. It's 80 degrees. 2 times 180 is 360. Divided by 5 is 72 degrees. I would cancel here. Just have smaller numbers. 6 goes into 180 30 times, and 30 times 7 is 210 degrees. Again, 20 goes into 180 9 times. 9 times 9 is 81 degrees. Okay, so as we talked about, remember, arc length, you're going to use the circumference formula. Okay? You're going to measure the angle, but remember, you're going to multiply it by 2 pi r, or pi d, depending on whether you have the radius or the diameter. And the area of the sector, pi r squared. And you're going to multiply both of those by the same thing. So for AB, right here, you're going to do 162 over 360. And you're going to do this twice. So to find the arc length, you're going to multiply by 2 pi r. And to find the area of the sector, you're going to use the area of the circle formula, pi r squared. So what's my radius? It's 10. So I'm going to change this to 10 and this to 10. 10 squared is 100. Remember, it says here, leave in terms of pi. So on the first one, you got 2 times 10, which is 20, times 162 over 360. If you multiply that out, you actually end up with 9 pi. And here you have 10 squared, which is 100, times 162, divided by 360. You end up with a nice whole number, 45 pi. Now we're just going to keep doing the same thing, AB. So 80 over 360 for arc length, 2 pi r, which is 5. And 80 over 360 for area of the sector, we're going to use the area formula, pi 5 squared, which is 25. Now when you multiply these out and reduce them, you get 20 over 9 pi. If you did it as a decimal, you got 2.2 repeating pi. We prefer to leave it as a fraction, but in case you did it as a decimal, that's what it is. And the area of the sector, 25 times AD over 360. That reduces down to 50 over 9 pi, or 5.5 repeating pi. Now be careful, 21 is not AC. It's the major arc ABC. So you need to do 360 minus 28, which is 332 degrees for a central angle. So, again, 332 over 360, 2 pi r, which is 4. That's for arc length. And 332 over 360. For sector area, we're going to do pi 4 squared, which is 16. Now when you do that, and reduce it down, you get 332 over 45 pi, or 7.38 pi. And for the area of the sector, again, 16 times 332 over 360. It's got to play with reducing it. It doesn't go very far. 664 over 45 pi, or 14.75 repeating pi. All right. This time they just give you the information, but it's going to be the same problems. 30 over 360, 2 pi 3, and 30 over 360, pi 3 squared. 9. Okay? Well, if you take 2 times 3 is 6 times 30 is 180. 180 times 360 is 1/2. So that's 1/2 pi. You really don't need to do a decimal, that's pretty simple. Over here you got 3 squared, which is 9, times 30 is 270. Well, that's just 3/4 of a circle, 3/4 pi, or 0.75. 90. Well, right off the bat, you can do 90 over 360, but if you recognize that's 1/4, you can do 1/4 2 pi 8 radius, and 1/4 pi 8 squared. Well, 2 times 8 is 16. 16 divided by 4 is 4 pi. 8 times 8 is 64. Divided by 4 is 16 pi. And last but not least, don't forget this is the diameter, so we want a radius of 10. And then again, it's going to be 72 over 360 times 2 pi 10. And 72 over 360 times pi 10 squared. Well, if you do 2 times 10 is 20 times 72 and divide by 360, you actually end up with a whole number again, 4 pi. And 10 squared is 100 times 72 over 360 ends up being 20 pi. And last but not least, 2 ways to go about this problem, but if you recognize that this is 3/4 of the circle, technically it's 270 over 360 times pi 7 squared, right? Okay. Well, that's really just 3/4 of the circle, so you end up with 36.75 pi, or 36 3/4 pi feet squared. Okay? And then last but not least, we basically have 2 circles here. And since this is 2 plus 3, we have a small circle with a radius of 2, and we have a larger circle with a radius of 5. All you're going to do is do the area of both. So we have the big and we have the small. So pi r squared, so 5 squared, and pi 2 squared. We're leaving it in terms of pi, which is nice actually, because then we end up with 25 pi minus 4 pi, which is just simply 21 pi inches squared. And that's it.